First of all, I was just listening and I was a little disappointed that no one from Northern California is in the ITP program, and want to make sure that we're working together to try to get some high schools up there to know about the program and so they can apply, because this is obviously and a very important part of manufacturing as well. So it's and that's the field that I'm in. And the number one and two reasons that were shown that for first year ITP students, uh, that definitely needs to be emphasized to high schools. I felt very compelled to be looking at a major that offers both a business and a manufacturing and engineering uh, major all in one. So just for those that don't know me, I'm Bill Gaines. I graduated from Cal Poly in San Luis Obispo in 1972 with a BS in mechanical engineering. I've been in the engineering field for 53 years, starting off with General Motors. A matter of fact, I think Andrew has mentioned that he was at Tesla. Well, I was at GMAD Fremont to start with, and also at Southgate plant before moving to central office where I was a senior tooling and manufacturing engineer. After my stint at GM, I decided to start my own business. I heard both, I think Andrew and Christopher have a side business, which is great. That really is something that a lot of us that get into Cal Poly, we eventually become entrepreneurs. And I wish I would have had a much better idea of what a P&L and a balance sheet was when I started my business. Um, the technology advances that I've seen over my career have been absolutely amazing. But that has been especially true in the last 2 years. I was using a slide rule to do all my engineering calculations when I first started the GM assembly plant. So you can imagine what has changed in those years. After my daughters and son-in-laws took over our plant in Chico, California in 2013, I got involved with many middle schools, high schools, community colleges, and universities. And my focus was to encourage education to teach the technologies that we are using every day at our facilities. And I am still involved in that even today. And I'm glad because I think I'm making a difference, or we are making a difference in getting education to teach the technologies. They're moving so bloody fast. So I'm going to move to my next slide. Did we get that? Yeah, we go. Okay, got about 20 minutes to talk about manufacturing, and I'll talk about the importance of manufacturing to the community, the equipment that we are currently using in manufacturing, what is currently being taught in Northern California high schools and community colleges, and a few of the skills that new employees must have to be hired in the manufacturing sector. I think this is really important. And how AI is currently being used in manufacturing facilities. I want you to look at this graph. I think we're missing out. And I just can't emphasize how important this graph is. This shows the economic input that each sector has to its community. And as you can clearly see, manufacturing outpaces every other sector. Now, you think this is just in Butte County. This is $616,000 for one manufacturing employee, as compared to $129,000 for a retail employee. This is what makes a community prosperous. And this is typical throughout the United States. And quite frankly, I'm so glad to hear that we're going to try to grow our manufacturing sector again. because it's going to offer the prosperity to both in the rural communities as well as suburban communities. If you think that's pretty interesting, in Solano County, which is Fairfield, Vallejo, near the Bay Area, that one manufacturing employee there is 146, I'm sorry, $1,467,000 versus a retail company employee of 117,000. That's 12 and a half times what a retail employee creates for its community. And you may ask why. This is such a huge disparity, and there are three major reasons. One is the refinery in Benicia, chemical engineers, Genentech in Vacaville, and the beer and wine industry. And the beer and wine industry, when you think about that, they're producing the end product. That's where the value comes in a product, is when you're selling it out to the retail wholesale markets. So we have to keep this in mind, that we need to grow the manufacturing sector in all of California. So when I started, I had a CNC plasma machine, which was great, but it held plus or minus 25 thousandths. This is what we use today. This is a Bystronic 4,000 watt fiber laser with a stacker destacker. And it has a very small footprint. It holds plus or minus a thousandth, and it can run lights out. That means 24 hours a day. And it can do multiple parts on the same sheet. It runs at twice the speed as the CO2 laser, which we had 6-7 years ago. So we're seeing the technologies just advance at just a remarkable level. Other pieces of equipment that we have at our plant include horizontal and vertical machining centers, CNC press brakes, cobots, keep in mind cobots, Fanuc link and welding robots, 3D scanners, CNC tube benders, and overhead conveyors for powder coating and an assembly line. The technology advances in the manufacturing sector have grown exponentially. AI is one example. We see AI being used as Copilot and ChatGPT. That's being used in marketing and advertising, sales, and in accounting. We're also seeing AI being used in engineering department for research and development, improving design methods, spending less time finding the latest regulatory requirements, and developing much simpler programs for testing our new products. It's amazing what that has done. I am not seeing AI being introduced into our production side yet, but that's going to come, of course. Filling hard to fill jobs is one of our biggest issues. As you can see, engineering, production managers, machinists, maintenance technicians, and that's more because of these advances in the technology. Both locally and nationally, the inability to fill positions at key are keeping us behind. We need educators to teach current technologies, starting in middle school all the way through to college. These kids know technologies. We just need to give them the opportunity to use them. Manufacturing is coming back to the U.S., as we all know, and finding qualified applicants is going to be an even more difficult job in the near future just because of that. This is our job board for TransferFlow Incorporated, and the jobs offered to high school graduates, junior college graduates, and university graduates are split into these three columns. those jobs that are highlighted in yellow are hard to fill jobs. As a matter of fact, um, we had to hire a press brake operator from Washington because back in 2013, there was no school offering, I'm talking about high schools or community colleges, offering curriculum to learn how to program a press brake. And I'll get back to that in a few minutes. But as you can see, the who we're expecting to hire for those positions as a high school graduate used to be over in the junior college graduate. We've moved that down, and I'll talk about that in just a few minutes. So these are the careers that TransferFlow offers. There's 40 different careers in our particular company, and they use SolidWorks, program Haas vertical machining centers using G code. They have to program our FANUC link and welding robots and our cobots. We use scanners to do all of our quality control. They need to learn that as well or have that skill level so that we can hire them. And that's becoming a big problem. That's been a problem for a long time. So I want to kind of show you what I am now seeing in high schools. When we were in high school, we had pre-World War II equipment when in the various different shops, but that's not the case today. Today we're seeing CNC plasma machines are in almost every Northern California high school that I visit, and I visit 26 Northern California high schools. I visit 3 community colleges and Chico State University. Now in high schools, they're using SolidWorks, CorelDRAW, or Fusion 360 to create 3D models of what they want to build. The models get converted to a DXF file and to create the cut part on a CNC plasma machine. Several high schools now have 3D printers. The students create 3D models and then transfer them to STP files or STL files so that the 3D printer can use that data, that information, convert it to G code and make the plastic part. When I toured the 26 high schools and 3 community colleges and university in 2013, not one high school or community college was teaching how to program a CNC press brake, a vertical machining center, or a welding robot. In fact, they didn't even have the equipment in their schools. Today, 5 Northern California high schools have CNC press brakes, and 4 high schools have vertical machining centers and are teaching G code and how to use it. Having the ability to form the cut sheet in a CNC press brake allows students to build more complicated student projects. And this is what you're going to start seeing coming into the Cal Poly. So they already have these abilities that starting as a freshman in college. Regarding welding at the 26 high schools, and now they're now teaching pulse welding, TIG welding, and how to operate low wattage lasers. They use the lasers to etch logos onto cups and also signs for both schools and retail stores. Now we're going to go to the community college. While no community college I visited had vertical machining centers or CNC press brakes in their labs in 2013, today all 3 community colleges have this type of equipment. The same community colleges also have several of the 3D printers and use 3D modeling software to build projects such as the Briggs & Stratton engine that I saw at Shasta College. We use our 3D printers to not only build jigs and fixtures, but we also use them to do prototyping of a part and for building low volume products. 3D printers, 3D, I'm sorry, 3D printing a prototype is a great way to validate a design before spending money on a die set. At least one community college is now teaching their welding students how to program welding robots. So this is what you're seeing for transfer students and what technologies they already possess. What grade do you think designed these pieces of artwork? Anybody have an idea? I'll wait for hearing something.
So we're hearing some freshmen. Any other? Eighth grade? Kindergarten?
Well, the kindergarten was the closest, it's fourth grade. And I want to tell you a little bit more about this. This is Durham Elementary School, which is just south of Chico. These students are from all ethnicities and economic levels. These young students know technology if our teachers give them a chance to use it. Most of us remember high school shop classes, at least in my generation, which were welding, auto shop, wood shop, and drafting and machining. In the 60s, the classrooms had pre-World War II pieces of equipment in them. During that time frame, we used the slide rules through high school and college. That's my era. Now, manufacturing needs to upgrade the equipment every 5 years to just stay competitive. For middle school on, and the technologies we are currently using, such as 3D printers, scanners, welding robots, and AI, need to be first learned by our educators and then taught from middle school up, not just to a few lucky students, but to all students. And this is pretty much the end of my presentation. Good, I beat the time. And so if you have any questions, I'm more than happy to answer them.